Good evening, everyone. Welcome to GoClasses. Is the audio video volume, is everything clear? Is everything fine? Let me know. Okay. Is the voice clear? Is there any echo? You can let me know. So let's start now. So this is standard question session 2 for digital logic. If you want to watch the session 1, then you can find the link in the description. Okay. So the playlist digital logic standard questions. Okay. This playlist you can find in the description. Now, in this session, what we will do, we will solve the questions of Cambridge University. Okay, University of Cambridge questions we will solve on Boolean algebra and minimizations. So let's start now. So let's start with with the first question. So you can notice this is a 2022 question of the Cambridge University. And if you go to this link, then you will find all the exam papers, but you don't have to solve them. See, many questions in these papers, many questions are not relevant for GATE exam. Many questions, they are either too complicated, like okay, they are beyond GATE exam, or some topics which are not in the GATE syllabus. Okay, so I am taking all the GATE questions, all the GATE relevant questions I am taking. So if you follow our standard sessions, okay, if you follow this playlist of digital logic standard question sessions, if you follow this, that is enough, because all the GATE relevant questions I will take. Okay, so let's start now. So let's start with the first question now. So tell me, okay, so let's solve this question. The question is saying that show that x bar y exclusive or x y bar is equal to x bar y or x y bar. So this is what we have to show. See, before we solve this question, actually this question is a very nice question. Okay, the target is not to solve. See, this question you can very easily solve using our method. Do you remember which method we apply? In the lectures we have already seen which method we apply. What is the best method to solve this type of questions? The best method is by case, correct? So this we have already seen, by case method. That is the best method we have already seen. Many questions we have done using this method, by case method. Oh, sorry. Sorry for that. Okay. Sorry for that. So, okay. Okay. Now it is visible. So what I was saying, yeah, okay. So so what I was saying, so these are the Cambridge University questions. This is what I was saying, Boolean algebra minimization. So let's start. As I told you that all the questions are standard questions. If you follow this playlist, then you don't have to worry about, then you don't have to solve these questions, because I will take all the GATE relevant standard questions I will take. Now this is the first question. Let's start with this question. So in this question we have this, so these two we have to prove. We have to show using Boolean algebra that these two. So what is the best method? We have already done many questions on this method in the class. So tell me, what is the best method for these questions? The best method is by case method. Many questions we have done. This is the best method to solve this question. Now the first question is saying, what the first question is saying, that x y bar exclusive or x bar y, this is same as x y bar or x bar y. Okay, this is the question. So let's solve this question. Now in this question, let's call it LHS. So this is, let's call it LHS, or let's call it RHS. So we have two sides. Now in this by case method, you already know what we do. Take one variable, any variable you take. So how many cases are possible if you take one variable? See, only two cases are possible. Case 1 is when x is 0, and case 2 is when x is 1. Only two cases are possible. No other case is possible, right? Only two cases are possible. So whatever you do, only these two cases are possible. So let me just do it. So this is the question. Now let's see. So one case is x equal to 0, another case is x equal to 1. Only these two cases are possible, because x is a Boolean variable. So x can take only two values, either 0 or 1. So only two cases are possible, either x equal to 0 or x equal to 1. Now when x is 0, then what is LHS? When x is 0, so remember, you already know one thing we already know, that this, when we write like this, x y bar exclusive or x bar y, when we write like this, then tell me what this means. Please tell me what this means. Does it mean like this? Okay, does it mean like this, or does it mean like this? What this means? Can anyone tell me what this means? Like, who has more priority? This exclusive or has more priority, or and has more priority? So there is and here. So we already know that and has more priority. And has more priority than XOR. Okay, so this is the priority order. You know that this negation, this not has the highest priority, then and has the priority, then or has the priority. Okay, so these are the orders. So this is the order basically. This is the order, and has actually more priority than all other operators. All the other operators are like this, but there is no order among them. There is no standard order. Okay, there is no standard order. There is no standard order among the remaining do not have any standard order, but they all have less priority than or. Okay, so the most priority is not, then and, then or, and the remaining operations, they do not have any standard order. Okay, but they have less priority than or. So I can say this is correct, this is not correct. Okay, now let's see. So let's see now. So tell me, only two cases are possible, x equal to 0, x equal to 1. When x equal to 0, then what is LHS? Then x equal to 0, then this will be 0. Okay, x equal to 0, so it will be 0, and x is 0, so this will be y. So it will be 0 exclusive or y. And what is that? 0 exclusive or y. Remember, if y is 0, this is 0. You already know, if y is 0, this will be 0. If y is 1, this will be 1. So this is same as y. This is same as y. So I can say 0 exclusive or y, 0 XOR y, that will be same as y, because if y is 0, then this will be 0, and if y is 1, then this will be 1. So I can say 0 XOR y, that is y. What is RHS? When x equal to 0, then what is RHS? Then RHS will be x equal to 0, so this will be 0. Okay, this will be 0. When x equal to 0, then RHS is also y. So you can notice they are same. You can notice they are same in this case. So when x equal to 0, in this case, both are same. Now, when x equal to 1, then in that case, what will happen? X equal to 1, so this will be 0. X equal to 1, so it will be XOR. Okay, y bar XOR 0, because x equal to 1, so this will be 0. Now, y bar XOR 0, that is y bar. And what will be RHS? RHS will be what? Because x equal to 1, so here this will be 0. So finally x equal to 1, so this will be y bar. So here also both are same. So in both the cases, okay, only two cases are possible, either x equal to 0 or x equal to 1. Only two cases are possible. In both the cases, you can see that LHS is equal to RHS. This LHS is equal to RHS in both the cases. Whether case 1 or case 2, in both the cases, LHS is equal to RHS. LHS is equal to RHS. So finally, this is the proof. And this is a very easy proof, yes or no? This by case. By case method is the most easy method if you want to prove these questions. This is very easy question. Okay, so this we have done. Very simple. This question we have done. Now let's see the next question. The next question, okay, similarly you can solve this question by case method, you can apply. Okay, so can I give this question as a homework? Can I give this question? Okay, on this question you can apply the by case method. The question is very simple. Anyway, let me take this question also. So this is a easy question. So let me take it. X bar y bar XOR xy is equal to, okay, xy by XOR xy is equal to x bar by bar, or okay, XOR. So here just apply the by case method. Only two cases are possible, either. Okay, so you know that case 1, what is the case 1? Let's call it LHS, let's call it RHS. So two cases are possible, either x equal to 0, another case is x equal to 1. Only two cases are possible, there is no other case possible, only these two cases are possible. And this by case method, this is most efficient. See, if you apply the truth table, if you solve this question using truth table, or if you expand this exclusive OR, this will take a lot of time. Okay, see, many students, what they will do, they will open this exclusive OR. This is what they will do, they will open this exclusive OR. So you know that A exclusive OR B, okay, that is equal to A bar B or A B bar. So this is what many students will do, but this is inefficient. If you open this actually exclusive or if you open this, then that will be inefficient method. So the best method is by case method. Only two cases are possible, x equal to 0, x equal to 1. In this x equal to 0, in this case what will be LHS? In this case, because x equal to 0, so this will be 0. So I can say 0 because x equal to 0, so it will be 0 exclusive y bar, and that will be y bar. What is RHS? RHS, because x equal to 0, so this will be 0. Okay, x equal to 0, so RHS is also y bar. Again, you can notice both are same. Again, you can notice they both are same. So in this case, LHS is same as RHS. And also in this case, when x equal to 1, in this case, what will happen to LHS? X equal to 1. Okay, x equal to 1, so this will be 0 because x equal to 1. So finally, I can say 0 exclusive or x equal to 1 y. So this will be y, and RHS will also be y. So again, you can notice that these two are same. Okay, these two are same. So in both the cases, case 1, case 2, only two cases are possible because x is a Boolean variable. So Boolean variable is either 0 or 1. So in both the cases, you can see LHS is equal to RHS, and this is the proof. Okay, in both the cases. So we have proven that LHS is equal to RHS. So this by case method is very nice method. Okay, very simple. So this question also we have done. So both the questions we have done. Now tell me one thing. Okay, I want to ask you. See, we have done both the questions, but this is not enough in this question. This is a very nice question. Let's do complete analysis. Can you see a very beautiful point here? Okay, please observe. There is a beautiful point in this question. This question we have done, but this is not complete analysis. And in Go classes, we always do the complete analysis, right? Okay. So what we have done in this question that you already know, we have done this question. What this question is asking, we have done this. We have proven it. Okay. We have given you the proof. But this is not complete analysis. One very beautiful point. Okay. And that point is very important because when we study adder, okay, in the combinational circuit, we will study carry look ahead adder. There is a combinational circuit for addition. So in that adder, this point we will use, the point that I'm going to tell you now, that point we will use. Okay, so can you observe very beautiful point you can observe here? So let's do that observation. So let's see that. So here, if you observe, let me tell you here what is happening. Can you notice what is this? What is this? Can anyone tell me? Can anyone tell me? Like, okay, here, what is this? Like x y bar x or x bar y. What is this expression? What can I say about this expression? Can anyone tell me? Can anyone tell me what is this expression? X y bar or x bar y. This is same as x exclusive or y. Okay. And you can notice what we have proven. We have proven that this is same as x y bar exclusive or x bar y. So actually what we have proven, we have proven that this expression is same as x y bar exclusive or x bar y. Okay, this is what we have proven. This is what we have proven that x okay, this is what we have proven that x exclusive or y is equal to x y bar exclusive or x bar y. This is what we have proven, and this is a important point. Now let me tell you what is the beauty of this question. Okay, let's do the complete analysis of this question as we do. Okay, in Go classes, this is what we do. So let's do the complete analysis of previous question. Okay, let's do the complete analysis of previous question. So let me tell you what is the beautiful point in this question. Okay, you will like that point. Okay, and the point is very simple. Just tell me this point. Okay, please tell me in which situation these two will be same. Okay, like A or B, this is same as A XOR B. In which situation? In which situation A or B is same as A XOR B? In which situation? In which situation they are same? If they are same, then okay, which situation they are same? Tell me. A or B that is same as A XOR B in which situation? In which case they are same? So you can notice they are same in all cases except when both are 1. Except when both are 1. Okay, yes or no? Except when both are 1. So they are same in all cases when except when A comma B both are 1. Correct? Yes or no? Because when both are 1, then in that case you can very easily see this is your A, this is B. Now okay, this is the truth table 0 0 0 0 0 1 1 0 1 1. So this is the standard truth table, you know. Okay, this is the standard truth table 0 1 2 3. This is the order. This is your standard truth table. Now what is A or B? A or B will be 0 1 1 1, and A XOR B, what that will be? That will be 0 1 1 0. So can you notice this case? Okay, please notice this case. Now in this case you can notice they are different. In all other cases they are same. In all other cases, so I am saying that A or B is equal to A XOR B in all cases except when both are 1. When both are 1, then in that case they will be different. Okay, correct, very simple. This point. Now from this point, just tell me one thing. If I give you two expression, let's assume you have two expressions. Let's assume you have two expressions. See here, A comma B, these are Boolean variables. Okay, here this A comma B, these are Boolean variables. These are not expressions, these are Boolean variables. Now so here A comma B are Boolean variables, but if I take two expressions, E comma G, if I take two expressions, then tell me, and if I, okay, two expressions I have, this E comma G, two expression I have. If I tell you, if it is known, if it is known, if I tell you that they both can never be one simultaneously, if it is known that E comma G are never are never one simultaneously. Okay, are never one simultaneously, means if they are never one, means they are never one simultaneously. If it is known that they are never one simultaneously, then I can say that A, E or G is same as E XOR G. Is this point clear or not? Is this point clear? Like if I give you two expression, I give you two expression E, okay, E comma G, two expressions I give you. For example, let's assume that this E is AB. Let's assume this E is AB, and this G, I give you two expressions, and this G, let's assume this G is, I can say, I can take some function. So this is function AB, and let me take A bar. Okay, this is the function A bar. Now tell me, please tell me, okay, is it possible they can be one together? Tell me, is it possible? Is it possible? Just tell me, is it possible that E equal to G equal to 1 for some combination? Okay, simultaneously. Is it possible that they are one simultaneously? Is it possible they are one simultaneously? Is it possible? Tell me. I am giving you two expressions, this expression, this expression. I am saying that these two expressions, if they are never one simultaneously, see, they can never be one simultaneously, because G equal to 1 when A equal to 0. Okay, so you can very easily check that you cannot make both of them one simultaneously. Correct? Yes or no? This AB and A bar, these two, they can never be one simultaneously. If you notice, this is AB. Okay, so this is 0 1 0 0 0 1 1 0 1 1. This is your expression AB, and AB is 0 0 0 1. This is AB, and G is A bar. G is A bar, so that is 1 1 0 0. Can you notice that? Can you notice this E comma B? They are never one simultaneously. Okay, they are never one simultaneously. They can be simultaneously 0, but you can notice they are never one simultaneously. Okay, these two are never. Is it possible that they are, okay? So the answer is no. They are never one simultaneously. Now you can see, because they are never one simultaneously, so now you can very easily see what will happen to E or G, what will happen to E XOR G. Okay, let's check it out. Tell me what will happen to E or G, E XOR G. E or G will be 1 1 0 1. E XOR G will be 0 XOR 1, that is 1. 0 XOR 1 is 1. 0 XOR 0 is 0. 1. Okay. So can you notice both are same? This and this. Can you notice both are same? So they are same. Yes or no? So please tell me, did you get this point? Did you understand this point? Did you understand this point that I am saying? I am saying that, okay, very simple point. Very simple point. E or G, this is same as E XOR G. This is same as E XOR G, except, okay, in all cases, this, okay, this is same. These two are same in all cases. These two are same in all cases, except when E equal to G equal to 1. Okay, correct? Okay, these two things, This E or G, this is same as E XOR G. These two things are same in all cases except when both are 1. So if it is known, if E equal to G equal to 1 is not possible simultaneously, this is not possible simultaneously. If this is not possible, okay, together, or I can say simultaneously, if this is not possible simultaneously, then I can say that then I can say that E or G, that will be same as E XOR G. Okay, please tell me, is this point clear? If, see, this is a very simple point. The point is very simple what we are saying. So in this, what we are saying, okay, so sorry for that, what is happening? Okay, just give me a second. Sorry, some technical issue. Okay, let me check it. Okay, so what I'm saying, so this point is very simple, that if you have E comma G, two functions you have, this E comma G, they can be anything. You have two functions E comma G, and we are saying that if they are never, okay, if this is not possible together, then I can say E or G is same as E XOR G. Let's do some practice. Let us do some practice. Okay, so I'm giving you E and I'm giving you G, and you tell me for which this will be satisfied, like for which this will satisfy. Can I say like E or G is same as E XOR G, for which this will be true? I'm giving you E, I'm giving you G, and you have to tell me for which this is possible. So for example, I give you AB, A or B. Tell me in this situation, yes or no? Okay, quickly tell me, yes or no? Is this true? E or G is same as E XOR G. Is this true? In this situation, E is AB, G is A or B. So definitely no, because they can be one. They can be one simultaneously. This AB and A or B, they can be one simultaneously. When AB both are one, then both will be one. So here I can say no. Okay, now tell me about this one. Like if I say A XOR B, A XOR B, what about them? A XOR B, A XOR B. Yes. Okay. So yes, I can say that E or B will be equal to E XOR B. So what we are saying? We are saying that this function XOR this function. See, this function XOR this function is same as this function. Okay, that is same as this function or this function. This is what we are saying, because remember, this is your function E, this is your function G, this is your function E, this is your function G. So you can notice this E comma G, they can never be one simultaneously. So okay, they can never be one simultaneously, this E comma G, they are never one together. So I can say that this, okay, this will be same as this. So this exclusive OR and this OR, they will be same. Okay, tell me, what about this f bar? Anything I take, any function I take, okay, any function I take f and f bar. If I take some function f bar, then in this situation, what will happen? Again, the answer is yes. Okay, so this means what? This means that f XOR f bar, that is same as f or f bar. Okay, both are same. F XOR f bar, that is same as f or f bar. Both are same. Is this clear? Okay, so many examples you can take, whatever example you want you can take. Okay, so that's the idea. Tell me this a bar b, what about them? A bar b, what about them? Again yes, again yes. Okay, and this is the reason, because you can notice a bar b, a b bar, okay, these two, and this is the reason I can say a bar b plus a b bar, this is same as a bar b XOR a b bar. And this is our first question. If you notice, this was our first question. If you notice, this was the question number 1 in the Cambridge assignment. In the assignment of Cambridge University, this was the question number 1. Correct or not? Okay. Is this clear or not? So you can notice, and the same thing I can say, if I make another table, let me make. So tell me about this one. Like if I say A bar, B bar, and AB, what about these two? A bar, B bar, AB, what about these two? They can be one. Is it possible that this and this, is it possible they can be one simultaneously? Is it possible they can be one? Both of them are one at the same time, simultaneously, together, simultaneously. Can they be one? No. So, okay, so here also answer is yes. Okay, next, tell me about this one. Okay, let me ask you, tell me about this one. A or B, A XOR B. What about these two? A or B, A XOR B. What about these two? Tell me. A or B, A XOR B. For these two, the answer is no. Okay, A or B, A XOR B. For these two, the answer is no. Because they can be one simultaneously. When A is 0, B is 1, then both will be one simultaneously. And tell me about this one. AB, A XOR B. AB, A XOR B. What about this one? AB, A XOR B. What about this one? For this answer is yes. And let me tell you, see, if you remember, okay, let me tell you. And okay, so if you remember that this is your question number 2. See, this is your question number 2 in the Cambridge University assignment. This was your question number 2, correct? This was the question number 2. This you can check it. You can check it out. This was your question number 2. So what I'm saying that this is the complete analysis. So you can this is your question number 2. So let me write it here. So this A bar B bar or AB, that is same as A bar B bar XOR AB. Okay, and this was your question number 2. Now can you see this question is very easy. Like if you already remember, if you already know this fact, just think about it, okay, and tell me. If you know this, then this question becomes very easy, right? If this question comes in the GATE exam, let's assume, and there are 4 options, and if you know this fact, then this question will become so easy, yes or no? And okay, just think about it. If there are 4 options, and in the 4 options you have this, like there are 4 options, and in the 4 options you have exclusive OR, then see, majority of the students, let me tell you, many students, what they will do, they will open exclusive OR. They will have like A exclusive OR B is equal to A bar B or AB bar. So they will open exclusive OR. Opening the exclusive OR will take a lot of time. If this is MSQ questions, there are 4 options, and if you open exclusive OR in all the 4 options, then like forget about that question, yes or no? So you will waste almost 3 or 4 minutes, you will waste in a question which is very simple. Okay, like many students, or I can say if anyone is watching this video, then definitely those students who are watching this video, they will be able to solve this question very efficiently. Okay, solving the question is fine, is a okay, solving the question is important, but solving the question by the best method, by the best efficient method, that is also important. Okay, so that is what we have seen. So this fact is very okay, and this fact is actually useful. Let me tell you, this Cambridge University question, this is not a, like this is not a random question. This is a standard question, and you can notice that this fact, okay, this look at this. Let me tell you, this we will use in the adder. This fact this will be used in adder. So when we study carry look ahead adder, so this will be used, and this is very important in carry look ahead adder. So this concept we will study CLA. Okay, CLA, carry look ahead adder. This concept, when we study this concept, at that time I will use this fact. This fact I will use. Which fact? This fact I will use, that A AB, okay, this AB or A XOR B, that is same as AB XOR A XOR B. Okay, this fact we will use in the CLA. In CLA we will use this fact, and this fact is very simple because you already know that if I give you this fact, okay, in the exam, if I give you this fact AB or A XOR B, okay, this is equal to AB XOR A XOR B, then you can very easily see that basically this and this, they are same. You can notice this is your E, this is your G, this is your E, this is your G. So you can check it out. They E comma G, they are never one simultaneously. E comma G equal to 1, okay, E comma G equal to 1 is not possible, is not possible, right? Okay, is not possible simultaneously. You can check it. Okay, this is not possible simultaneously. So finally I can say, that E or G is same as E XOR G. Okay, so so that's it. So this is the complete analysis of this question. I hope you got it, and this is a very simple question. You can notice, very simple question. Now this type of questions will become very easy for you. Okay, very easy they will become for you. So this type of question they can ask, like some variations. Let me create some variations. Like this question they can ask. They can ask, what is A XOR B? Okay, some options will be there. Some options will be like A B bar or A bar B. Okay, another option will be A B bar exclusive or A bar B. Okay, so like this some options they can give you. Okay, some options they can give you like this, A or B and A bar or B bar. Fourth, A bar or B, A or B bar. So tell me which of them are correct. Tell me about here. Okay, so which of them are correct? Four options you have. So which of them are correct? A exclusive or B, that is same as what? That is same as, we already know this is correct. We already know that A bar B plus A bar B. This we already know. But remember, this and this, they can never be one simultaneously. Very simple point. Very simple point, that A bar B or A B bar, and you can notice that this comma this, they are never one simultaneously. They are never one. They are never one together. They are never one together. So I can say this is same as, I can say A bar B or A B bar. Okay, that is same as A B bar exclusive or A bar B. Okay, so this option is also correct. This option 2 is also correct. This option 3 is also correct, we have already seen. And this option 4th is not correct. Okay, so 1 2 3, 1 2 3 are correct. Is this clear? So this is the complete analysis of this question. I hope you got it. Now let's move on. Let's move on to the next question. Did you understand this? Let me know. Very simple question. But now you know everything. Now, okay, now you know one, I can say, one very important point you know. Okay, remember this is not a random question. One thing about GATE exam I want to tell you. This is important thing I want to tell you. If you notice all the GATE exam questions, then see GATE exam, okay, will use the standard things. If there is like in the carry look ahead adder, this concept carry look ahead adder, in that concept this is used. Okay, I told you AB or A XOR B is equal to AB or AB XOR A XOR B. So in that this is used in books, or in all the standard books it is given. Okay, and they use it. So someday they will ask. Okay, the GATE examiner someday they will ask, like in graph theory. In graph theory, this Peterson graph is very important. If you see graph theory books, okay, if you study many graph theory books, then you will see for some of the books Peterson graph is the cover picture. Okay, in many of the books, on the cover you will find the Peterson graph. So Peterson graph is very important graph, and I will discuss. Okay, I will create a separate video on Peterson graph. And there is a question is 2022. In GATE 2022, there is a question, MSQ question, 2 mark question on Peterson graph. So basically, because Peterson graph is very important, Peterson graph is standard. So in the GATE exam, they ask, okay, they are last year they asked. Okay, so that is the point. Similarly, there is a concept in digital logic, static hazard. That concept we will study, static hazard. Okay, this concept. There is only one question in the GATE exam on static hazard. But let me tell you why that question came. That is not a random question. That question came because static hazard elimination, removal of static hazard is major application of K-map. So we will study this, don't worry. I will tell you what is static hazard, okay, how to remove static hazard using K-map. So if in the interview, if they ask you what is the application of K-map, then you can say minimization and also static hazard removal. These are the standard applications of K-map. Okay, so that is the reason GATE exam will ask this type of question. Okay, GATE exam is all about standard questions. Now let's move on and let's see the next question. So let's solve this question one. So let's see this. What this question is saying. So this question v function v is given to you. Okay, and the question is asking using the K-map, and this is also Cambridge University question, the same university. Now using the K-map, simplify the following Boolean expression y into product of sum, and we have to simplify, we have to basically minimize. So in the product of sum, so let's solve this question, and this is very simple. So 4 variables are given to you, so let's make a K-map on 4 variables. So let's create that. So you already know, very familiar, we have done a lot of practice of the k-map. So let's solve this question using the k-map. So first you create the k-map. Total 4 variables are given to you, a b c d. These are the 4 variables a b c d. And now, so you know this is the no, remember the question is talking about pos. The question is talking about pos. We want pos, so this will be a bar, this will be b bar, this will be c bar, this will be d bar. This is the area of d bar, because the question is talking about pos. We want pos, this is what we want. So that is the reason this is the area a bar, this area is a bar area, and I can say this area is b bar area, and you can check this area is d bar area, and this area is a c bar area. Okay, now let's see. So so because we want pos, so first let's fill this k map. Okay, let's fill this k map. A b bar c d, this expression, if you notice, so this will give you which min term? Can anyone tell me? This will give you which min term? This will give you which min term? This is min term. Tell me which min term you will get here. So you will get a b c d bar. It's like in the area of a. Okay, so okay, first let me fill it. Okay, after that we will discuss. So first let me fill it from that point of view, like from a b c d, from min term point of view. From one point of view, let me fill it. So I'm filling this k map from one point of view. So I will fill this k map using one entries. So you can notice a b c d bar. Okay, so this is the area of a b, this is the area of a, this is the area of a b, this is the area of a b c, and this is the area of a b c d bar. So this will be 1. Okay, remember, because of this a b c d bar, because of this is the min term. You can notice this is the min term a b c d bar, so that is the min term 14. So this is the min term 14. Very simple. And tell me about this one. What is this one? This is saying a b c d bar, a b c d bar. What this is saying? See, very interesting. You don't have to simplify this. Don't simplify this. What this is saying? This is saying when this will be 1. Just tell me when this will be 1. This will be 1 when a should be 1. So remember, this should be 1. This will be 1. This will be 1. So it means a should be 1, and it means bcd should not be 0. Okay, a should be 1, and bcd, sorry, bcd should not be 1. Okay, a should be 1, bcd should not be 1. So a must be 1, means this area. A should be 1, it means this area. This area is the a equal to 1. This is the a equal to 1 area. So this area. And bcd should not be 1. Here bcd is 1. If you notice here bcd is 1. So which entries we will get? These entries we will get. Very simple. Remember, a should be 1, bcd should not be 1. This is the meaning of this. The meaning is a should be 1, bcd should not be 1. So I can say a should be 1. This is the area where a is 1. So here a is 1, and you can notice here bcd is 1. So apart from this, bcd should not be 1. So finally these 1 entries we will get. Is this understood to everyone? Is this understood? And what this is? What this is? This is your a bar, b bar, c bar, d bar. So which area? This is the a bar, this is a bar, b bar, and this is a bar, b bar, c bar, and this is a bar, b bar, c bar, d bar. So this will be 1. So this is the k map that we got. This is the k map that we got. Yes or no? Yes or no? So now this you can solve very easily. Okay, another way. Let me tell you this a, b, c, d bar. Another way. What is another way? Another way is a, b bar, or c bar, or d bar. Okay, so this is how you can do. If you want the same question, you can do like this. The same question you can do like this. Okay, so this is the area where a is 1. This is the area where c is 1. This is the area where b is 1. This is the area where d is 1. These are the areas. Okay, so like this. Is this clear to everyone? So basically the first step is, from this expression you have to find the min terms. So you have to find the min terms, and these are the min terms. All the 1 entries that you can see, all these 1 entries are the true min terms. Here function value is 1. So from this function you have to find where this function will be 1. So this function will be 1 for these entries. For these 1 entries, you can notice for these 1 entries this function will be 1. Now let's see, the question is asking about POS. Okay, so if the question is asking about POS, then I will focus only on 0 entries. So these zero entries we will focus, because the question is asking about POS. We want POS. Okay, so because we want POS, so we will only focus on zero entries. So these zero entries we want. We don't want anything else. We only want zero entries, because the question is talking about POS. And you know that when we have POS, then basically this will become A bar, this will become B bar, this will become C bar, this, okay. So like this. All these concepts we have already seen in the class. Okay, so nothing new. We have already seen this. So this is the idea. Now tell me. So here, how many areas you will create? You want POS, you want minimum POS. So how many areas you are going to create here? So which area you will create? So okay, you will create this area, correct? Yes or no? This you will create size 4. This is the size 4 cube you will create. So what this will give you? With some term, you will get some term. So you will get a sum term. With some term you will get? You will get the sum term C bar. This is in the area of C bar or A. This is C bar or A. Okay, this is the sum term you will get. What is the next sum term you will get? For this, with sum term you will get here. This will give you A. This is in the area of A or D bar. Okay, A or D bar. Next, which next is this. Okay, so what is this? Can anyone tell me what is this? This is in the area of B bar or A or C. Okay, A bar, B bar, or A or C. And what is this one? So the last one, this one. So what that will be? This last one. So what that will be? That will be in the area of C bar or D bar or B bar. Okay, so finally your minimum expression, what you will get? You will get minimum POS, that you will get minimum POS, that will be C bar or A. Next, A or D bar, A or D bar. Next, B bar or A or C. Next, okay, C bar or D bar or B bar. So this is your minimum POS. This is the minimum POS we will get. Okay, is this clear? Oh, right. Oh, okay. So here actually we can take this. Instead of taking this one, we can actually take this one. Yes, okay, correct. Very good. So actually we can create this one. This one we can take. So here this we can extend like this. So this size 4 we can take. This size 4 we can take. So if we take this size 4, then this is the in the area of A or B bar. This is in the area of, okay, this is the, okay, so answer will be B bar or A. So answer will be B bar or A. This is correct. So this is your minimum POS. Yes, this is correct. Thank you, Sandeep. So some students have suggested, yes. So this is correct, because we can take this area. Very simple. Basically this 0, 0, 0, 0. We can take this area, we can take. Okay, instead of taking this area, we can take this area, because we want minimized expression. So we can take this bigger area. So finally answer will be this. This is the minimum POS. Okay. So this is your question. Can anyone tell me here how many prime implicants we have? Can anyone tell me how many prime implicants we have? How many prime implicants we have? First you tell me, is this essential prime implicant? Tell me, is this essential prime implicant? Can I say this is essential prime implicant? Is this essential prime implicant? Can I say this is EPI? Is this EPI? This one, is this EPI? No, this is the trick. This is the trick question. Is this EPI? This is not EPI. Is this PI? Tell me, is this PI, prime implicant? Tell me, Yuvraj, Sandeep, tell me, is this PI, prime implicant? Can I say this is PI? Is this PI? This is not PI also. Can anyone tell me what is the reason? Anyone tell me what is the reason? This is not PI, this is not EPI. Then what is the reason? This is neither PI, this is nor EPI. This is a trick question. So please take care. This is not PI, this is not EPI. What is the reason? Because remember this PI, EPI, these are group of ones. This PI, EPI. Okay, this PI means prime implicant. Prime implicant. This prime implicant, this essential prime implicant, these are group of ones. Remember, these are group of ones. These are product terms. These are product terms. These are not sum terms. These are not sum terms. Okay, these are product terms, not sum terms. Okay, okay, these are product terms. We have already seen. These are group of ones. These are group of ones, not group of zeros. These are group of ones, not group of zeros. This we have already seen. I told you this is a trick. This is a trick question. Is this clear? In the GATE exam, they will give you this. See, in the GATE exam, they will give you this type of K-map. In the GATE exam, they will give you this K-map, they will give you. And what they will ask, so for example, in the GATE exam, they will give you this K-map, they will give you. Okay, and they will ask, what they will ask? They will ask how many prime implicants. So this K-map they will give you, and they will ask you how many prime implicants, how many PI, and how many EPI. How many PI, how many EPI? What will be the answer? How many PI, how many EPI? So what will be the answer? Now, if you say answer is, see, if you say answer is 1 and 1, then that is wrong. That is wrong. If you say this is PI, if you say this is PI, this is EPI, then this will be wrong. This will be wrong. Okay, because remember, always remember this prime implicant and this EPI, they are group of ones. They are group of ones. They are not group of zeros. They are group of ones. These are product terms. I told you these are group of ones. These are group of ones. These are product terms. These are not sum terms. These are product terms. We have already seen all the definitions. Different definitions of this PI, EPI we have already seen in the class. Okay, so finally here what we will get? We will get 2. So this we will get. This will be PI also. This will be EPI also. And one more you will get this. This one you will get. This will be PI also. This will be EPI also. So how many PI, EPI? Answer will be 2, 2. Is this clear? So this is a trick question that I asked you. Please tell me. Do you understand? Okay. So in this question I am asking how many PI? If I ask you this question, so how many PI will be there? So let's see. If you want to find the PI, then you have to focus on ones. So let's find out which are the PI. Which are the PI? Let's find out the number of prime implicants. Let's find out. Okay, so you can notice that for this one there is only one choice. There is only one choice for this one. This choice we have. This choice. So this will be EPI also. This is PI also. This is EPI also. So this is your EPI. Okay, next you can notice that you can create size 4. See, you can create this size 4. You can create this size 4. Okay, so this is this size 4. This is PI also, EPI also. This is PI and EPI, both of them. This size 4. This is EPI because of this, and this is EPI because of this. Next what you can do? Next you can see that you can create this corner. Don't forget about this. Okay, this one. Never forget about this one. Okay, never forget about the folding one. Folding one. This is EPI also, PI also. This is EPI because of this. Because of this one, this is EPI. Okay, because of this one. Next, what else? Next you can notice that this will be the EPI. Sorry, this will be the PI. This, if you notice, this is your PI. This is the PI. And tell me, is this EPI? Is this EPI? Yes, this is EPI also. You can check, this is EPI also. This is EPI also because of this one. Because of this one, this is EPI also. So tell me how many PI, how many EPI? So what is the number of prime implicant? Number of prime implicant, that is 1, 2, 1, 2, 3, 4. Okay, total 4 PI and total 4 EPI. So number of PI and number of EPI, that is 4, 4. Clear? Very simple. So this is your question. Very simple question. In this question, this is the trick. Okay, please remember, this is the trick. This question is the trick. So don't follow 0, okay, 0, 1. This prime implicant and this essential prime implicant, these are product terms. So these are group of ones. These are not group of zeros. These are group of ones. Okay, so these are not group of zeros. Remember, these are not group of zeros. Now, let's see this question. So let's quickly solve this. Very quickly solve this question. Find minimum SOP, minimum POS expression. This is what we have to find. Find their literal counts. Find number of implicants, prime implicants and essential prime implicants. So in this question we have to do the complete analysis, and this function is given to you f a b c d, and this function we have. So let's see this one. So can you try? So this function we have f. So first you create the, again first you will create the k map. So let's create the k map first. A b c d, there are four variables. We have four variables a b c d, and okay, so these are these are the functions. So this is the area of a, this is the area of b. So here you can notice here a is 1, and you can notice here b is 1. This is the area of c, and this is the area of d. Means here c is 1, and it means here d is 1. Okay, so these are the areas. Now let's see this one. Let's find out. So tell me what minterms this will give you. Which minterm this will give you? A bar, B bar, C bar. See, you can directly make the entries. This is in SOP. If you notice, this is in SOP form. This is in sum of product form. Sum of product. So this is already in SOP form. A bar, B bar, C bar. So let's see, this is the A bar. This is the A bar area. This is A bar, B bar, and this is A bar, B bar, C bar. So this will be 1 1. Like this you can create the entries. Okay, directly create the entries. Yuvraj, see, Yuvraj, Sandeep, Abhipsa, all students, please notice, you can directly create the entries. A bar, B bar, C bar. Okay, this is the area of A bar, because remember this is the area of A. You can notice this is your area of A. So I can say this is the area of A bar, this is the area of A bar, B bar, and this is the area of A bar, B bar, C bar. Directly you can write. Okay, because this is your A bar, B bar, C bar. So I can write 1 1. Next, A bar, C bar, D bar. So notice this is A bar, I can say A bar, C bar, D bar. This is A bar, this is A bar, C bar, and this is A bar, C bar, D bar. Okay, remember this is A bar, C bar, this is A bar, C bar, D bar, this is A bar, C bar, D bar. So this will be 1 1. Next, A bar, B, C, D. This is A bar, this is A bar, B, this is A bar, B, C, and this is A bar, B, C, D. Next, A, B, C bar, D. This is A, this is A, B, this is A, B, C bar, and this is A, B, C bar, D. So this will be A, B, C bar, D. Next, A, C, D bar. Okay, this is A, this is AC, AC, D bar. This is AC, and this is AC, D bar. Remember, this is AC, D bar. So finally, this will be 1 1. Next, A, B bar, C. This is A, this is B bar, this is A bar B. See, this is A bar B and A bar B C. This is A bar B and this is A bar B C. So it will be this. Okay, very simple. So this is how you can fill. This is your K map. Now from this K map, let's find out. Let's find out all the things. So how many prime implicants? Please tell me. Let's find out all the prime implicants. So can you notice? Okay, this with this one, can I take something else? Tell me, this one with this one, can I take something else? Can I group it with something else? Can I make a bigger group? Can I make a bigger group? No, I cannot make a bigger group. So this I have to create. This will be PI also. This will be EPI also. And what is this? This is your, okay, this is same as, this is PI also, this is EPI also. And what is this? This is A bar BCD. This is your A bar BCD. Next, this is also EPI PI. This is PI also. This is PI also. This is EPI also. And this is what? And this is your A, B, C bar D. This is your A, B, C bar D. Okay, A, B, C bar D. Very simple. Next, for this one there is one choice. How many choice we have? For this one, how many choice we have? For this one, how many choice? There are only one choice. For this one, there is only one choice. This, because of this one, this is PI also, this is EPI also. This is PI also, EPI also, and what is this one? This is in the area of C. You can notice. This is in the area of C, area of A, and area of B bar. Okay, so this will be CAB bar. Next, because of this one, there is again one choice. Because of this one, there is only one choice. Only one choice because of this one. So this will be your, okay, this is also PI, this is also EPI, and what we have here, this is in the area of A, area of D bar, and area of C, area of A. Okay, next, So you can notice this is pi also, epi also. For this one, how many choices we have? Please tell me. For this one, how many choices? Only one choice you have. So this is the only one choice. So this is pi also and this is epi also, because of this one. Because of this one, this is pi epi also. So this is in the area of a bar, c bar and d bar. Okay, this is a bar, c bar, d bar. Next, finally, the last thing, the last is this one. Okay, this is a last one. So I can say that this one, and this one you can notice because of this one, this is pi also, this is epi also. And what is this expression? This is in the area of a bar, in the area of c bar and in the area of b bar. A bar, c bar, b bar. So finally, how many pi are there? How many pi? So what is the number of pi? You can check number of pi, that is how many. So you can notice pi. Okay, so total 6 pi we have, and all of them are epi. Every pi is epi. So how many? Okay, every epi is covering all ones. Okay, epi, you can notice. Okay, epi is covering all the ones. EPIs are covering all ones. What it means? If they are covering all ones, then what it means? It means you have unique, it means you have unique minimum SOP. Unique minimum SOP you have. Okay, minimum SOP is a unique. So you have unique minimum SOP because EPIs are covering all the ones. So okay, so you can notice, and actually let me tell you, this itself is, if you notice, this itself is minimum POS, minimum SOP. This itself is minimum SOP. You can check it out. This you will get if you check it out. Okay, so you will get this F. Okay, so number of pi this, number of EPI this, unique minimum SOP you will get. Now let's find out what we find out. What is the literal count? What is the literal count here in this expression? What is the literal count? How many literals we have? Number of literals. What is the literal count? Literal count is 3 plus 3 6, 6 plus 4 10, 10 plus 4 14, 14 plus 6 20. So literal count is 20. Okay, so in this expression the literal count is 20. Now we have to find POS expression also. In the same question we have to also find POS expression also. So let's find out POS. In this question let's find out POS. So for POS, what we have to do? We have to focus on zeros. If you want to find POS, then you have to focus on zeros. You don't have to focus on ones, you have to focus on zeros. If you want to find the if you want to find this, okay, so this is what you want to find. Okay, so you have to focus on zeros. You don't have to focus on ones, you have to focus on zeros. If you want to find EPI, sorry, POS, minimum POS you have to find. So let's see this one. So tell me here. So what are the cubes that you will create? The cubes that you will create, what are the cubes? The same structure, yes or no? If you notice, you will get the same structure. Here also you are getting the same structure you will get if you check it out. So this you will get, this is a unique, this is unique, and you can check this, you will get the same structure. Actually structure did not change. Sometimes the structure will change, but here the structure did not change. Okay, here the structure did not change. So actually you are getting the same structure. So you are getting the same structure in this question also. So there will be, if you notice, there will be unique POS. Here you will get unique POS, you will get unique POS. Okay, so the structure did not change. The literal count is also same. The literal count is also same in this unique minimum POS. So you will get unique minimum POS and literal count is also 20. Okay, so for this question the structure did not change. But remember, sometimes it will change. Remember one thing. For example, take this one. Okay, take this one. Remember these things, like, okay, if you have minimum POS, then can you guarantee you have minimum SOP? Tell me, if you have minimum POS, can you guarantee there is minimum SOP? This is my question. My question is, if you have, this is my question. Can I say literal count of minimum? This is my question. Literal count of minimum SOP is the same as literal count of minimum POS. Is this correct? Is this correct? Literal count of minimum SOP is same as literal count of minimum POS. Is this statement correct? True or false? And the second question, if minimum SOP is unique, if that is unique, can I say minimum POS is unique? If minimum SOP is unique, if minimum SOP is unique, then can I say minimum POS is unique? Okay, so for both the questions, answer is no. For this question, answer is no. Okay, for example, you can check, like if I give you this question. Now here you can notice in this question, the minimum POS, if you find the minimum POS, then minimum POS will be only this one. This will be the minimum POS. So your minimum POS will be actually, this is in the area of C, or this is okay, because if you find the minimum POS, so let me find it. If you find minimum POS, then this is the area of A bar, this is the area of A bar, this is the area of B bar, this is the area of C bar. And if you find minimum POS, then this will happen. So you will cover zeros. So this is in the area of B bar or C, area of B bar or C. So you can notice in this literal count, what is the literal count? The literal count is 2. But if you notice, if you find minimum SOP, in the same question, if you want to find minimum SOP, then you will cover ones. Okay, you will cover ones. These ones you will cover. Okay, so these ones you will cover. Okay, like this. So you can check it. So here, actually, okay, for this question, actually, literal count will be same. Okay, so for this is actually okay, so this is your area B bar and this is the area C. So your minimum SOP, that will be B bar or C. Okay, so here actually literal count is same, but actually this is not same. In general, this is not same. This literal count of SOP, literal count of POS, here in this example they are same in this example, but they are not same always. Okay, so which example you can create? Can anyone give me a counter example where you have different literal count for can anyone give me a counter example? So Sandeep is saying 2 3 5 7. Okay, so 0 1 2 3 0 1 2 3 4 5 6 0 1 2 3 4 5 0 1 2 3 4 5 6 7. Okay, so this example, will this example work? Will this example, so here you have unique minimum SOP. Minimum SOP is unique. And what about minimum POS? That is also unique. So actually this will not work. Sandeep, this will not work. This example will not work. Okay, can anyone suggest some example where minimum, actually in the class we have already seen this. So do you remember some example where we will get minimum SOP and minimum POS? Okay, you will get different, like number of SOP, number of minimum SOP is different from number of minimum POS. So can anyone suggest some example? In the class you can see your lecture notes, maybe you can check your lecture notes. So some example we have already taken, like okay, so some example we have already taken. So let me check it out, what can be done. If I take this one, yes, okay, so this example will work. This is correct example. This example will work, you can check it. Here you will get how many what is minimum SOP. This example will work, you can just check it out. This example is going to work. So you can notice that, okay, in this example this is EPI. You can check, this is EPI because of this one, because of this one this is EPI, and because of this one this is EPI. So these are EPI. But you can notice, to cover this one, to cover this one, either you can take this, either you can take green one. Say either you can take this green one, either you can take this green this one, or you can take this one, or you can take this one. So minimum SOP will be 2. How many SOP will be there? Minimum SOP will be 2. This is, you can notice, this is the area of A, this is the area of C, this is the area of B. So finally this what is this? This is your area of A bar and B bar, A bar, B bar. And what is this one? This is in the area of AB. And this red one, let's see this red one, this red one, this will be in the area of C, A bar. So finally your minimum SOP, that will be A bar, B bar, or AB or C, A bar. So this is one minimum SOP. Another minimum SOP is possible here. Another minimum SOP will be A bar, B bar, or AB, or this one. Okay, so what is this? You can notice this is PI but not EPI, but not EPI. This is PI but not EPI, and here you can just check it out. So for this one you will get, this is in the area of BC. Okay, so you will get BC. So you can notice two minimum SOP you have. So number of minimum SOP, that is 2. Number of minimum SOP, that is your 2. But you can notice there is unique POS. Okay, if you focus on zeros, if you just focus on zeros, there will be unique minimum POS. You can just check it out, this and this. So you will get unique minimum POS. Unique minimum POS. Okay, so unique minimum POS that you will get, that is a B, or so that is B bar, or C, or A, and so you can just check it out, because see, this is the area B bar, this is the area A bar, this is the area C bar. So finally what this will be, this will be in the area A bar, in the area A bar or B. So you can check what is the literal count. Tell me what is the literal count. What is the literal count of minimum POS? Literal count is 5. And you can notice what is the literal count here. Okay, what is the literal count? The literal count, what is that? Literal count is 6. So okay, so this example will work. You can check, this was our question. Our question was this: literal count of minimum SOP is same as literal count of minimum POS? Answer is no. Okay, and similarly, if minimum SOP is unique, then okay, so anyway, so this is the idea, very simple. So this example will work. Okay, so this is another question. Can you solve this question? This is very simple. ABCD, this function is given to you, and these are the minterms, these are the true minterms. So here your function value is 1, and the question is asking, first you simplify this, and the question is, second question is, how many equal complexity solutions are there? Basically the second question is asking, what the second question is asking? The second question is asking what is the number of minimum SOP. The question is asking what is the number of minimum SOP. Number of minimum SOP. So this is how many minimum SOP are there. Number of minimum SOP expressions. Okay, how many number of minimum SOP expressions. So you can just check it out. Okay, can I give this question as a homework? Please tell me. This question as a homework. You can write your answer in the comment. Okay, please write your answer in the comment. So how many, what is the number of minimum SOP? You find this and you write the answer in the comment. Okay, what is the number? How many SOP are there? So this number you write in the comment, and also this minimum expression, all the minimum expression you write in the comments. Okay, so this question I can give as a homework. Yes or no? Can I move on? Can I give this question as a homework? Similar question we have done. Okay, so 2-3 questions we have done already. So you can just take it, this question as a homework, and write your answer in the comments so that your answer is not wrong. And the second part is very simple. How many equal complexity solutions are there? It means how many minimum SOP expressions are there? This is the idea, Nikhil. How many equal complexity solution? What this means? See, if I give you 2 expression, look at this. If I give you 2 expression, like in this previous question, look at this in the previous question. Here you have minimum SOP. How many? 2? Okay, 2 minimum SOP you have. In the previous question, we have 2 minimum SOP. One minimum SOP was A bar, B bar. Okay, one minimum SOP 1. Minimum SOP 1. What is that? That is A bar, B bar, or AB, or C A bar, or C A bar. And what is minimum SOP 2? What is that minimum SOP 2? Minimum SOP 2, that is, that you can notice. So that is A bar, B bar, or AB, or BC. You can check that this has, what is the complexity? Means basically here you can notice there are 3 terms. There are 3 terms, 6 literals. There are 3 terms, 6 literals. Okay, and here also you can notice there are 3 terms, 6 literals. There are 3 terms, and 6 literals. I can say this is the complexity of the expression. Okay, these 3 terms 6 literals, here also 3 terms 6 literals. So that is the reason this is also minimum SOP, this is also minimum SOP. This is the complexity of expression. I can say this is the complexity of expression. This is the complexity of expression. So you can notice both the expression, these two expression, they have 3 terms 6 literals. These are the 3 terms, this is a term, this is a term. So total 3 terms are there. Here also 3 terms you have, and total 6 literals. So these two expressions have same complexity. So all the SOP, remember, all minimum SOP, there can be many minimum SOP, all minimum SOP have same complexity, because what is the meaning of minimum SOP? Minimum SOP means minimum number of terms. Okay, minimum SOP means minimum number of terms, and minimum number, and each term as small as possible, and each term as small as possible, as small as possible. Okay, so this is the idea of minimum SOP. You should have minimum number of terms, and every term must be as small as possible. So all minimum SOP, they have the same complexity. You can notice 2 minimum SOP you have, and they have the same complexity. Okay, both. See, the first priority is number of terms. Number of terms is the first priority. If whenever you are finding minimum SOP, whenever you are finding minimum SOP, the first priority is minimum number of terms. Minimum number of terms. This is the first priority. Number of terms must be minimum. And the second priority is each term as small as possible. Each term as small as possible. Is it clear? So whenever you are finding minimum SOP, then this would happen. Same thing for minimum POS. The same thing will hold for minimum POS. You should have minimum number of terms. This is the first priority. And the second priority is each term as small as possible. Okay, let's move on. So this question is for your homework. Please write your answer in the comments so that you can verify. Okay. So whoever will give you the correct answer, okay, we will pin that comment. That comment we will pin. Okay, let's see this one. This is a simple question. Which property is this? X plus y dot x plus y bar. This is what we have to prove. So which property is this? This is a simple question we have already done. Very simple. X plus y dot. So you can just actually, this is very easy to prove. X plus y bar. This is what we have to prove. Okay, this is what you have to prove. Then very simple, just multiply. See, just multiply them. If you multiply them, then what you will get? If you multiply them, then you will get xx plus xy bar plus yx plus yy bar. Okay. Now this yy bar, this is 0. Yy bar, this is 0. This is xx, that is same as x. Next, so finally you will get x plus xy bar plus xy. Now this is the absorption property. You already know a plus a anything. See, a plus a anything, that is same as a. This is known as absorption property. Okay, we call it absorption law. So here also the same law you can apply. X plus xy. So this will be absorbed. This will be gone. Similarly, x plus this will be gone. So finally you will get x. And this is your absorption property. So this question is very simple. And this is your consensus property. This property is consensus. In the class we have seen. So this property is consensus property. I told you how to remember this. Okay, so this is consensus. This is simple question, and you can just check it out. You can solve this. Which is the best method to prove this? To prove this, what is the best method? If you want to prove this, then what is the best method? The best method is by case method. Okay, so just apply the by case method, and this is the best method to prove this. Very simple. So you can do it. In the class we have done it. This is another question. Using Boolean algebra, simplify this. Okay, let's simplify this using Boolean algebra. We need to simplify this question. So first expression x is given to you, and the x is saying what this x is. Using Boolean algebra we have to minimize. So a bar bc plus b c bar whole bar plus BC. Okay, so let's do this. So here first you can apply the De Morgan law. In this question, first you can apply the De Morgan law. So just apply the De Morgan law here. Here you can apply the De Morgan law. So you will get A bar BC plus what this will become? What this will become? This will become B bar or C plus BC. Okay, so this will become, remember you can apply the De Morgan law. So if you know the De Morgan law, AB bar, that is same as A bar or B bar. This is the De Morgan law you can apply. So you will get B bar or C. So here you can check this property we know. What is the property? This property we know A or A bar anything. That is same as this A bar will be gone. This A bar will be gone. This property we know. And this is important property like A or A bar anything. Then in this situation you can cancel this. In this situation, you can remove this A or A bar alpha. Then you can remove this. So it will be A or alpha. Similarly, if you have A bar or A alpha, okay, you can notice A bar or A alpha, then you can remove this. Okay, so you can remove this. Basically, this is what you can do. A bar or A alpha, then what you can do, you can remove this. So finally, you will get A bar or alpha. So here the same thing you can do. First of all, you can apply absorption property here. So if you apply absorption property here, this will become C. So you will get this plus B bar plus C. So this you can apply absorption. You can apply the absorption property C or BC. Okay, C or BC, C or BC. So it will be C. This is the absorption property. Now let's see the next. This is again absorption property. Here or here, you can apply the absorption. This is also absorption property. So your final answer, what is the final answer? The final answer will be B bar or C. This will be your final answer, B bar or C. Okay, so this is very simple question. We have done this. So the answer for this question will be B bar or C. Okay, so this will be the answer, B bar or C. And this question you can take as a homework. Again, you can answer what is the simplified expression, you can answer in comments. Okay, so what is the simplified expression for this question, you can answer in the comments with the time stamp. Okay, also put the time stamp. So you can take this question as a homework because we have done this question. Similarly, you can do the question number Y. Just apply the De Morgan theorem. Okay, first you apply the De Morgan law. So when you apply the De Morgan law, this will become A bar, B bar, C bar. Okay, then you apply these rules. Okay, this is absorption law. So these three rules are important. You can apply them. Okay, let's see the next one. So this is another question you can just okay, very simple question. So what this question is saying, first we have to prove this A or BC equal to A or B, A or C. This we have seen in the class. This you can do by case method. Okay, just apply the by case method. Okay, you can prove. So you can prove this using by case method. This is very simple. This is your distributive property. Actually, this is nothing but distributive property. A or BC, that is same as A or B, A or C. Okay, this is known as distributive property, and the proof you can do using by case method. This is the distributive property. Another distributive property is this. This is another distributive property, AB or AC. So these two are called distributive property. Okay, so these are our distributive property. Now you can do the proof using by case method. I leave it up to you. So you can do it. I know I have confidence on you. So you can do it. Now let's see this question. The question is saying that using this property, express the following equation as product of some, okay, something like this. So this equation we have to express. Okay, so this very simple. So basically you need to express this as a sum. Okay, like this you have to express. Like this you have to express this. Okay, so this should be a sum term. Like this you have to express. This should be a sum term. 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 So like this you have to express. So let's express this. This is not very hard. This is very simple. F is given as H or ij bar or k bar L or k bar L. So let's solve this. This is very simple. So how will you do this? So here how will you do this? Very simple. You think this as alpha. See, just think it as alpha. Okay, let's think this as alpha. So okay, maybe think this as A. If you think this as A, then what we will get? If you think this as A, then you can apply the De Morgan distributive property. A or K bar L, that will be same as A or K bar A or L. Okay, like this you can do. So just think this as A. If you think this as A, then you will get A or K bar L. A or K bar L, that will be A or K bar A or L. So you will get this I can say H or I. Okay, what you can say, H or K bar or I J bar. Also you will get H or L, H or L or I J bar. Okay, so this is what you will get. Very simple. Now again what you do, again you think it as, B. Think it as B. Okay, so here you think it as C. So finally what you will get? If you think this as B, then what is a B or I J bar? What is B or I J bar? What that will be? That will be B or I, B or J bar. Very simple. Just apply the distributive property. So what you will get? You will get H or K bar or I, H or K bar or J bar, H or L or I, H or L or J bar. Okay, so this is the answer you will get. Finally, this answer you will get. And this is what the question is asking. Okay, the question is asking that you have to express this as a product of four sum terms. This is the question that is asking. The question is asking that every sum must have three variables. Every sum term must have three variables, and you have to express this as a product of four sum terms. Okay, product of four sum terms. Product of sums. Okay, four sum terms. I can say product of four sum terms. Product of four sum terms, I can say, with four sum terms. So answer will be this. Okay, very simple. The question is very simple. We are applying this method. Remember, A or B bar C. What you can write it? A or B bar C. Using the distributive property, you can write it A or B bar, A or C. This fact we are using. And you can notice, if you consider this as A, then you can write like this. And then if you consider this as B, then finally you will get your answer. So very simple question. This is the last question for today, and this is very nice question I want to take. Okay, so let's solve this. This is the last question for today. In this session, this is the last question we will solve, but this is a very nice question. Okay, like this is one of my favorite question in the Cambridge assignment. Okay, so this is a very nice question. Let's solve this question. So the question, okay, read the question. Please read the question one time. Let me remove my audio. This. So let's see. Let's read this question. Read this question. What this question is saying? So the question is saying that write down the truth table of a logical unit. There is a logical unit. So there is a logical unit. We have a logical unit defined in the following table that can execute one of the four logical operations at a time. Okay, that can execute one operation at a time. Okay, so there is a logical unit. We have a logical unit. This is your logical unit. So this is a circuit. Basically, this is a digital circuit. We don't know what is this circuit, but there is a digital circuit. So this is the logical unit. And what this logical unit does, it executes one operation at a time. Okay, one operation at a time on two data inputs. There are two inputs, y1, y0. Okay, there are two inputs, y1, y0. On these two inputs, the question saying on these two inputs. Remember, on these two inputs. So remember, on this is. So this logical unit will perform these operations. These operations will be performed. These operations will be performed on these two inputs, y0, y1, to yield output z, and the output is a z for this unit. For this logical unit, the output is z. And this is control. There are two control input. This logical unit has two control input. Two control input means this logical unit has two control input, I1, I0. There are two control inputs. Inputs you have. And okay, and the question is saying, what the question is saying, see, when the inputs are I0, okay, when the inputs are 0, 0, these two inputs, when they are 0 0, then you will get OR, then you will perform OR operation. So what this unit is doing, see, very simple, what this logical unit is doing, this logical unit, what this is doing like this. So there are two control inputs. The control inputs are I1, I0. These are the control inputs. These are the control inputs, but these are inputs. Remember, these are control inputs, but these are inputs, and these are also inputs. So total four inputs we have. Total four inputs we have, and this is output. This is the output. And what this question is saying? The question is saying that, very simple question, that when I1, I0, when they are 0 0, when these control inputs are 0 0, then what will be the output? Tell me, what will be the output? Can anyone tell me? When input, you can notice, when I0, I1, I0, when they are 0 0, then what will be the output? Output will be OR. OR of what? The output will be OR of what? Y1 or Y0. Correct? Yes or no? Because remember the question, read the question. We are performing on these two inputs. Okay, like this is the idea. See, if these are 0 0, these control inputs, if these are 0 0, then output will be what? If these are 0 0, like if this is 0, this is 0, then output will be Y0 or Y1. Okay? If these are 0 0, then output will be Y0 or Y1. This will be the output. Next, you can notice, if inputs are 0 1, if I1, I0, if they are 0 1, I1, I0, they are 0 1, then you will perform AND operation. Then you will get AND operation, Y1, Y0. This is what you will get. And if both are 1 0, then you will get XOR operation. When both are 1 0, then you will get XOR operation, means Y1 XOR Y0. And when both are 1, then what is happening? See, when both are 1, then what is happening? NOP. And this meaning is given to you. The execution of NOP implies Z can take any binary value. What this means? Can anyone tell me? See, the execution of NOP implies Z can take any binary value. Z can take any binary value. It simply means that Z is don't care. In this situation, we don't care about the value of Z. We don't care about the value of Z. In this situation, we do not care about the value of Z. Yes or no? Because remember, the execution of NOP, the execution of this operation. So when I1, I0 are 1 1, then this operation will execute, and we don't care about the value of Z. Z can take any binary value. Z can take any binary value. It simply means that we don't care about, okay, what this means? This means that we don't care about Z. Okay, we don't care about Z. We don't care about Z. So in this situation, I can say whatever Z happens, we don't care. Very simple. So this is the logical unit. Okay, and tell me one thing. This Z is a function of what? This is a function of what? This is a function of what? This Z is the output. This Z is function of what? It will depend on whom? This Z will depend on whom? Tell me. This Z will depend on I0, I1, Y0, Y1. This Z will depend on these four. Yes or no? This Z is going to depend on these four. Z will depend on all these inputs. These are also inputs. These are also inputs. So the Z will depend on all these four things. Okay, so finally I can say your Z, this Z is a function of, this is a function of I1, I0, Y1, Y0. This is a function of I1, I0, Y1, Y0. So you can write this function like this. Okay, so you can fill this table like this. Now let's make the K-map, because remember what we want to do. The question is asking to create a truth table. So let's create a truth table. The truth table will not take much time. So truth table you can create. I leave it up to you. Okay, let me just, the truth table will be like this. I1, I0, Y1, Y0. These are the four variables, and this is your function. Remember, Z is a function of, Z depends on I1. Z will depend on I1, I0, Y1, Y0. Z will depend on all these four things. Okay, tell me about this one. 0, 0, 0, 0. What is Z? 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. In these four situations, what is Z? So you can notice in these, when both are 0, 0, When I0, I1, when both are 0, 0, you can notice when both are 0, 0, in this situation, when both are 0, 0, the output will be Y1 or Y0. So when both are 0, 0, the output will be Y1 or Y0. The output will be Y1 or Y0. Yes or no? So this Z will be Y1 or Y0, Y1 or Y0, Y1 or Y0, Y1 or Y0. Okay, so output will be like this. Similarly, you can fill this table. Okay, tell me 0, 1, 0, 1, okay, 0, 1, 0, 1, 1, 0. What will happen in this case? Tell me. What will happen in these two cases? You can notice when they are 0, 1, when they are 0, 1, then you will get Y1, Y0. Then you will get Y1, Y0. So you will get 0, 1 like this. I am not creating the complete table. I am just telling you what is the meaning. If both are 1, 1, if both are 1, 1, okay, then tell me what will happen if both are 1, 1. Then it will be don't care. If both are 1, 1, then it will be don't care. Okay, when I, okay, and if both are 1, 0, if both are 1, 0, then what will happen? Then you will get XOR. When both are 1, 0, you will get XOR. So it will be 0. Okay, the remaining table you can fill. I am not filling the complete table. Okay, the remaining table you fill. Remaining table you can fill. The remaining table you can fill. Okay, so very simple. The remaining table I leave it up to you. Total 16 rows are there. You can notice total 16 rows are there, so you can fill it. Now let me make the K-map. I can directly make the K-map. I don't need this truth table. I can directly make the K-map. So let's make the K-map directly. In the K-map, what will happen? Let's see. In the K-map, so you have I1, I0, Y1, Y0. Okay, so this is the area of I1, this is the area of I0, this is the area of Y1, this is the area of Y0. So let's fill this table. Now you can notice, tell me, okay, so tell me, so when both are when both are 0, I1, I0, when both are 0, means in this situation, tell me here what will happen. Here in this area, look at this area. In this area I can say both are 0. Look at this area. In this area I can say I1, I0 is equal to 0, 0. Both are 0, 0. So in this situation, what you should get? So in this situation you should get Y1 or Y0. Okay, in this situation your function Z should be equal to Y1 or Y0. Okay, your function Z, I can say your function Z, this function Z, this is your function Z, so this should be Y1 or Y0. So you can notice this will be Y1 or Y0. So this you will get. Okay, this is done. Next, and this is 0. This is a 0. So you got this. Next, tell me. Similarly, this area, when okay, this area, what is this area? Look at this area. Tell me what is this area? This area is I1, I0 equal to I1 is 0 and I0 is 1. This is 0, 1 area. So this is the 0, 1 area. In the 0, 1 area, you should get Y1, Y0. Okay, so your output should be Y1, Y0. So here you should get Y1 and Y0. So actually you will get this. This you will get here. And tell me what about this area? What about this area? So you can check it. What about this area? This area is I1, I0 equal to, both are 1, 1. In this area, both are 1, 1. So here don't care, don't care, don't care, don't care. Okay, here our function will be don't care. And finally, in this area, you will get XOR. You will get XOR of, so here you will get 0, here you will get 1, here you will get 1, and here you will get 0. Okay, so this is what you are going to get. Please tell me, is this clear to everyone? Did you get this? How I am feeling? See, you don't need this truth table. You don't need to create this truth table. Okay, without creating the truth table, you can directly see. You can directly do. Okay, just do. Okay, very logically you do. This first row, this row is when both I0, I1, when both are 0, 0. So this is 0, 0 row. Okay, so here you will do Y0 or Y1. Okay, so like this you can do. This question is very simple question, but this is interesting. The question is very simple, and GATE exam is all about this type of question. In the GATE exam, they will give you simple questions, but you have to analyze. You should analyze. Okay, questions will be easy, but you have to analyze. Now let's see. Okay, so what is the minimal expression? Can we create a size 8? In this, can we create a size 8 cube? In this question, size 8 cube we cannot create. There is no size 8 cube. So let's focus on size 4 cube. So what are the size 4 cubes that are possible? With this one, how many choices I have? Okay, first you tell me, with this one, how many choices I have? There are two choices. Either I can do like this or I can do like this. There are only two choices. Okay, so how many pi will be there? See, focus on pi. So this is a pi. I can say this is a pi. I can say this is a pi. And you can also notice this is a pi. This is a pi. So this is what you can do. Next, okay, what else? For this one, how many choices you have? Again, two choices. For this one, you have two choices. This is a pi and this is also pi. So there are two choices again for this one. This is a pi, this is a pi. For this one, okay, you have two choices. For this one, how many choices? There is only one choice. So this is EPI. This is a EPI. Oh, sorry, no, no, no. Okay, there are again two choices. No, no, because there are again two choices. These two choices you have. So I can say this is a pi. I can say this is a pi and this is also a pi. Okay, like this is also pi. Next, you can notice that this is also pi. This is another pi and you can check it out. So this is another pi. And finally, this is also pi. This all the don't cares. Okay, this all the don't cares. This is also creating a pi. But this is not EPI. This all the don't cares if you take. All the don't cares. If you take this row, if you take this row, then this is also pi. This all the don't care. This is pi, but this is not EPI. Remember, if you have all the don't cares, then you have pi, but you don't have EPI. EPI must have at least one. Okay, in the EPI you must have at least one. That is the idea of EPI. So, did we forget about anything else? Tell me, are we forgetting about anything else? Is everything else is covered? So, what is the number of pi? Tell me what is the number of pi finally. So number of pi that will be, you can just check it. So this is pi, this is pi, this is pi, this is also pi. Okay, this is also pi. So how many times I have written pi, you can just check it. Pi, this is also pi. And I think we forgot about this one. This one we forgot about. Okay, so this is also pi. This is also pi. We forgot about this one. So I think answer will be 1, 2, 3. Okay, and this is also pi. So this is pi, this is pi. For every pi, I have written that it is a pi. So your answer finally, what that will be. So, okay, 3, 4, 5, 6, 7, 8. I think 8, right? Is this correct? Okay, just count. What is the, like you can count, very simple, I think. So you can just count. So that will be 2, 3, 4, 5, 6, 7, 8. I'm getting 8. 1D at the top. Only this one we will get. Pi, 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 pi. 4. Pi, pi, pi. Which pi I am missing? Can anyone tell me? At the top right. Oh, this one I'm missing. Okay, okay, okay. So I think this one we missed. This one is also pi. So number of pi will be total. Number of pi will be total 9. And you can check there is no EPI. Okay, in this you can check there is no EPI. So there is no EPI here. Correct? You can check. There is no EPI in this question. There is no EPI. We do not have any EPI in this question. So there is no EPI. But okay, number of pi is equal to 9. And you can find the minimum expression. So from this you can very easily find the minimum expression. So what will be minimum SOP? Minimum SOP that you will get. So in the minimum SOP, you will not take this. So just cover once. You have to focus on covering once. So you can just find the minimum SOP. Okay, I can give this as again homework. Okay, so you can find the answer and you can find in the comments. Or maybe okay, let's solve this actually. Okay, so this is a nice question. Let's solve this. So this is a mess up. Okay, so let's solve this one. So we have to write minimum SOP. So to write the minimum SOP, what I can do, see, I can pair this with this. If I pair this with this, then I can pair this with this. And then what I can do, I can pair this with this. So I think we will get unique. If you notice, we will get unique. I think unique minimum SOP we will get. Unique minimum SOP we will get. Remember, there is no EPI. If you notice, there is no EPI. In this question, there is no EPI, but still, we will get unique, minimum SOP. Minimum SOP that we will get, that is unique. You can just check it. Okay? Yes or no? Correct or not? The minimum SOP that we will get, that is unique. Only 3 terms we need. If I do something else, then I need more terms. If I do anything else, I will need more terms. So I think you will get unique minimum SOP. Yes or no? Is this clear? 3 terms you will get. So there will be 3 terms. You will only get 3 terms. 3 terms are enough. Okay, so what is this red one? This red term. What is this red term? This is in the area of, you can notice this is in the area of I0 bar, and this is in the area of Y1 bar, and this is in the area of Y0. And what is this one? What is this one? This is in the area of I0 bar, this is in the area of Y1, this is in the area of Y0 bar. And what is this green one? This green one is in the area of I1 bar, this is in the area of Y1, this is in the area of Y0. So finally you will get minimum SOP that you will get. Okay, that is Z equal to, your function is Z, so Z is equal to I0 bar, Y1 bar, Y0, or I1 bar, Y1, Y0, or I0 bar, Y1, Y0, Y0 bar. Okay, so this is your answer. Can you notice, you will get unique minimum SOP. Okay, is this clear? So in this question you have no API. There is no API in this question. There is no API, but still minimum unique SOP. Okay, so this is the idea. Now you can notice that. so this note you can take. This note you can take. Even if there is no, even if, okay, so even if there is no EPI, even if there is no EPI, we may or may not get. We may or may not. We may or may not get minimum SOP. The same thing will hold for minimum POS. Okay, for minimum POS also the same thing. Even if there is no API, then also we may or may not get minimum SOP, minimum POS. Okay, so that's it. This is your questions. So this is a very nice question. This is, you can check it. Okay, so the simplified expression the question is asking, we have done this, both of them we have done, and this question is very simple, very nice question. So please tell me, did you understand all the things that we have seen? Did you understand all of them? So in this lecture we have seen a lot of concepts we have seen in this lecture. Please let me know, did you understand? Like, did you get something new? See, all these concepts we have already seen in the class. All these examples, some variations, these are some variations. Okay, these are not the questions that we have done in the class. In the class we have done similar type of questions, but all the similar type of questions we have done in the class. But these questions are variations. Okay, remember, every new question will need your analysis. So you should improve your analytical skills, because in the GATE exam the questions will not come from notes. If the questions are coming from your notes, then everyone can do it. Okay, but in the GATE exam the questions will be new. Okay, some questions will come from your notes, some questions will be new. But if your analytical skills are good, if you can do good analysis, if you do complete analysis of everything. See, in Go classes what we do, like in the first question what we did, in the first question we solved the question, but solving the question is not enough for us, you know this. Okay, so we did the complete analysis of that question, like what is happening. Okay, so that is what we have to do. Okay, so if you understand all the things that we are covering, all the things if you understand, then you can very easily crack the GATE exam. Okay, so improve your analytical skills, and please let me know Please let me know, okay, if you understood this. If you understood everything, please let me know. So let me see the chat. Diptanshu is saying, how can we get minimum SOP? See, you can get minimum SOP, many minimum SOP you can get. Diptanshu, see, look at this question, this previous question that we have done. Look at this question. In this question, you can notice there are two minimum SOP. This is also minimum SOP. This is also minimum SOP. Which is more minimum? Can you say, Diptanshu? Which is more minimum? Like, can you say which is smaller? Two expression you have. This is also SOP expression. This is also SOP expression. This is also SOP expression. Here also you have three terms 6 literals. Here also you have three terms 6 literals. So tell me, which of them is smaller? Can you tell me which expression is smaller? Both expressions are fine. Yes or no? Both expressions are correct. Both expressions are small. Both expressions have three terms and both expressions have 6 literals. So both are small. Both are equal. I can say both are equally small. I can say both these are equally small. I can say all minimum SOP are equally small. I can say they are equally small. I can say they are equally small. So this is the idea. Okay, is this clear, Diptanshu? Anyone has any other doubt? So these are some questions from the these are some questions from university, this Cambridge University. Okay, so this type of sessions we will take, more sessions we will do. And so if you like the session, then you can press the like button. Okay, so you can put the comment also, so that we can reach more students. All these quality questions, this quality analysis, this complete analysis, if you want more students should learn from this, or it should reach more students, then you can like, comment on all these things. Okay, share and all these things, so that you already know you are very intelligent. Okay, so and so that's enough. So next Sunday we will again have this type of class. Actually today I wanted to solve a lot of questions. In the session 1 we have done around 30-40 questions we have done. In this session we have done around maybe 10-15 questions. So total we have done in today session 1, session 2, in two session we have done around maybe 50, 60, 70, I don't know. Okay, so these many questions we have done in today's session. Okay, and today what I'm going to do, see what I'm going to do today, I will upload Boolean algebra, all the GATE previous year questions, GATE PYQs, all the GATE PYQs of Boolean algebra, all video solutions I will record. Actually, I have already recorded and I will upload. Uploading is, I can say, only uploading is remaining. I have already recorded all the previous year GATE questions, video solutions, detailed video solution with complete analysis. Okay, so what you can do, if you are not on the, see, all the complete course students, if you are already a complete course students, all the complete course students of 2023. Okay, so if you are GATE 2023 complete course student, go classes GATE 2023 complete course student, if you are, okay, then then today you will get the access. You already, some of you already have the access. Today you will get the access to GATE PYQ video solution course. Okay, GATE PYQ video solution course. This course, many of you already have this access. This course you already have, but if you don't have this access, then we will provide it to you. Okay, and in this you can go and you can find the digital logic. Today I will upload, in the digital logic I will upload the all the Boolean algebra previous year GATE question video solution. I will upload with the complete analysis, so you can solve those questions and then you can watch the video solution. Okay, from the video solution you will get something more. Okay, okay, thank you everyone. So and some maybe, okay, so you can, if you are not go classes students, then you can consider. Okay, if you want, you can enroll for the go classes complete course. So this is GATE 2023 complete course, you can enroll. Okay, in this course everything you will study with proof, so there is no rote learning. Okay, in our course there is no rote learning. Okay, everything that we teach from the basics. So in this lecture actually we have done questions. All the concepts we have already seen in the our lectures. In the digital logic 2023 course we have already seen all the concepts from the basics. Okay, So there are weekly quizzes. Every week there is a quiz, and there are GATE PYQ video solutions, summary lectures, and okay. So there is Telegram support. All these things you have. So if you are not Go Classes students, then if you are preparing for GATE CSE 2023 or 2024, then you can check out our website. Okay, on the Go Classes website, you can check the GATE 2023 and 2024 complete course. Okay, and also you can enroll for the Go Classes and GATEOverflow combined test series. So for this combined test series, you can enroll in this combined test series. In this combined test series, you will get 15 mock tests, more than 100 quality tests you will get. So to enroll, you can visit this website. Link you can find in the description. Link of test series, link of this course, GATE 2023, GATE 2024. If you want to take 2-year course, 2023 plus 2024, 2-year course if you want to take, you can visit our website. Okay, on this website you can visit. So you will get the 2-year course. Okay. Also this test series you can enroll, and you should attempt the Boolean algebra test. Okay, to all the Go Classes students, I want to tell you that okay, in the test series, in the Go Classes test series, in this test series you attempt the Boolean algebra test. Okay, in this test series today, okay, today you attempt the Boolean algebra test. This Boolean algebra plus minimization, this test is there. Boolean algebra plus minimization. Okay, so this test you should attempt. All the concepts we have seen in this test, you will see some original questions, some nice questions you will see. So this test you should attempt. Okay, okay everyone, thank you so much. And you can also join our Telegram group. So you can see in this combined test series, you will get quality questions, no ambiguity in the questions, every question is well framed. Okay, there are detailed explanations, and for some tests already video explanations are there. For all the tests, video solutions will be provided, but right now at this moment, for 2 or 3 tests, video solution are available, detailed video solution are available, but for the remaining test also video solution will be provided. Okay, and also discrete mathematics, complete discrete mathematics and C programming. These 2 courses are freely available on Go Classes website. So you can visit the Go Classes website, and there you can check it out, discrete mathematics and C programming. These 2 courses are freely available for all learners, free, and the complete courses like lectures, homework, weekly quizzes, everything. Okay, all the lectures, all the homework, all the weekly quizzes, everything is freely available in this course. Okay, so you can check it out. And okay, to join our Telegram group, if you want to if you want to ask your doubts, for doubt discussion, you can join Go Classes Telegram group, and this is the username, and the link you can find in the description. Okay, so you can read the description on the YouTube on this video. Under this video, just go and read the description. There you will find all the links, link of test series, link of this Telegram group, link of complete course, every link you will find. Whatever link you want, you can find there. And if you have any doubt, you can put a comment. Okay, all the questions that I have given as a homework, those questions you should solve and write your comment. Okay, 2 questions I have given, I think 2 or 3 questions I have given as homework. So put your comment with the answer. Okay, and whoever will give the correct answer, one comment we will pin, so that future students can see that comment. Okay, so thank you everyone, thank you so much. See you next Sunday. Okay, thank you, bye.